Okay, in this video I'm going to show a couple of examples about how to calculate a subnet based on IP address and a subnet mask. So for starters, just so I can have an example IP address to work with, I'm going to find out what the IP address on this machine is. And let's use 160.10.25.96. Okay, let's have a mask. Let's start by using a mask of 24. Since this is a very common one we'll see. This also corresponds, as we'll see in a minute, 255.255.255.0. You probably use this as a subnet mask when you configured your a static address on your Windows machine, possibly when you did some configuration of your broadband router. We see this one a lot, so it's a good place to start with. When you see this particular notation, what it means is that all right, let me back up a bit. Before you can calculate a subnet based on an IP and a net mask, you have to convert your IP address to binary. And the easiest way for this, I pull up Windows Calculator and the Windows 7 version. I switch the view to the programmer view. I look at each octet individually and find the binary for that. And let's pull the back up. The binary for 160 is 1010 followed by 4 zeros. So that's the binary for 160. The binary for 10, I just happen to know, is 0000. 1010. Think a minute. I'll put the binary calculator and do 25 is going to be 0001 followed by 1001. We have to pad it out to a full 8 bits. For 96 is 0110 followed by 4 zeros. Now back to the mask. When we use the slash notation in a mask, we take the number after it, start at the left, and write out that many ones. So we have a 24, so we're starting at the left, we'll write out 24 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and then the rest of our mask is zeros. 1, 2, 3, 4, 5, 6, 7, 8. Now we perform a little bit of Boolean algebra on these ones and zeros. Anytime we have a 1 and a 1 together, our result is 1. Anytime we have a 0 and something else, our result is 0. So 1 and 1 is 1, 0 and 1 is 0, 1 and 1 is 1, 0 and 1 is 0, 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 dot, 0, 1 is 0, 0, 1 is 0, 0, 1 is 0, and we keep doing this. And I assure you that it looks like this for the rest of our thing. Now we take all of these and convert them back to binary. And let me make some space for doing that. So if you pull up your Windows calculator and you were to convert each of these fields back to binary, I assure you you would get 160.10.25.0. You just calculated the subnet portion of an IP address based on a mask that I gave you. This one was pretty easy because we use the .24 mask. If you look at 8 ones, say here, they correspond to 255. Same for that octet, same for that octet, and of course 8 zeros is still 0. In this particular case, so let me see if I can copy all this over and start a new page. Thought I was going to stop. There we go. We could have simply just used our shortcut, which is to say, if we see a 255, we quote what's above it. So 10 and 255 is 10, 255 and 25 is 25. Then if we see a 0, we just bring a 0 down. We can do that in decimal, and it works for a couple other masks as well. That's the .16 mask, and there's the .8 mask. In each of these cases, if you saw a 255, you would just quote back what goes in that position, and if you see a 0, you put a 0 in that position. These are the easy masks. Slightly harder are when you have some that don't fall on the nice multiple of 8 boundaries. So let's use the same IP address, 160.10.25.96. Now let's use a mask of /17. Actually, we'll do 18. Works pretty well. So I'm going to go back and copy my binary. There we go. Give me a second to clean things up a bit. Alright, so that's the binary for 160.10.25.96. Now we have a mask of 18, which means once again, we start at the left and count out 18 ones. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then the rest are zeros. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Same rules apply. Only in this case, well, again, same rules apply. Everywhere there are 2 ones, we put a 1. Anywhere there's a 0, we put a 0. So if we do the math, if you look here, we have 0, 1 gives us a 0, 0, 1 gives us a 0, and then the rest are zeros. So if we convert this back to decimal base notation, 160, 10, 0.0.0. So using this IP address with this mask gives us that subnet. So hopefully this will clear up any confusion you have about how these are calculated. Fortunately, when we get to IPv version 6, this gets a lot easier. But right now, this is how we divide up the network portion versus what we call the host portion of an IP address. Again, if you have questions, just let me know by email or pronto.